What happens when the most massive object in a galaxy escapes the forces meant to confine it? For decades, astronomers have asked whether a supermassive black hole could be expelled into intergalactic space. After years of theoretical work and indirect clues, astronomers have finally answered that question with the first direct observation of such an event. Instead of remaining anchored at the center of its galaxy, a supermassive black hole is actively fleeing its home. It is not drifting or oscillating. It is racing through space at nearly 1,000 kilometers per second, moving faster than a speeding bullet through the cosmos. This breathtaking speed allows it to escape its galaxy's gravitational pull completely. This marks the first direct observation of a runaway supermassive black hole and fundamentally reshapes our understanding of how violently galaxies can evolve. Nearly every large galaxy, including the Milky Way, hosts a supermassive black hole at its core. These objects contain millions or billions of times the mass of the Sun and act as gravitational anchors that govern the motion of surrounding stars. Astronomers long believed that once a supermassive black hole settled at a galactic center, it stayed there permanently. That assumption no longer holds. Using data from the Hubble Space Telescope and other observatories, researchers studying a distant system known as the Cosmic Owl Galaxy Group identified an extraordinary object. At a distance of roughly 8.8 billion light-years, they detected a compact, extremely massive body tearing through intergalactic space. By analyzing the gravitational influence of the object on nearby stars and gas using spectroscopic techniques, astronomers determined a mass of approximately 10 million times that of the Sun, thereby firmly classifying it as a supermassive black hole. To measure its velocity, they observed the redshift in the light from the material surrounding the black hole. This data indicates that the object travels at approximately 1,000 kilometers per second, roughly 0.3% of the speed of light, fast enough to escape its original galaxy and enter intergalactic space. Astronomers detected this black hole not by its light, but by its impact. Black holes emit no light directly, but the material around them does. As this object plows through surrounding gas, it compresses and heats the material ahead of it, forming a bow shock similar to the wave created by a fast-moving ship. Behind it, the black hole leaves a glowing trail of gas and newly formed stars that stretches tens of thousands of light-years. This luminous wake exposed the black hole's path. In effect, the black hole is drawing its trajectory across the universe. Scientists have proposed several mechanisms capable of ejecting such a massive object. One involves galaxy mergers. When two galaxies collide, their central black holes can form a binary system that orbits each other under their mutual gravitational influence. If a third black hole later approaches and enters the gravitational field of this binary system, it can create a volatile three-body interaction. The gravitational forces among the three black holes are complex, and this can lead to one of the black holes being ejected at high speed.
Another mechanism involves gravitational waves. When two supermassive black holes merge, they release enormous amounts of energy as ripples in space-time, as predicted by Einstein and confirmed by observatories such as LIGO. If that energy radiates unevenly, the newly merged black hole experiences a powerful recoil, a gravitational kick that can propel it out of the galaxy entirely. This observation strongly supports those theoretical models. Until now, astronomers had identified runaway supermassive black holes mainly through simulations
or indirect signatures. Direct observation confirms that galaxies are not tranquil systems. They are sites of extreme interactions, where even the most massive objects can be displaced. In a universe shaped by constant collisions, galaxies can occasionally fling their heaviest components into intergalactic space. As the black hole moves through space, its gravity accretes surrounding gas, triggering star formation in regions that might otherwise remain empty. These trails may trigger the formation of small groups of stars in the empty areas of space, but scientists remain uncertain whether they can form entire galaxies. To visualize this process, imagine an artist scattering paint across a blank canvas. The paint represents pockets of gas pulled along by the speeding black hole, which act as the foundation for new celestial formations. Occasionally, the strokes of the brush are so dense and concentrated that they create clusters of stars, while more dispersed areas might coalesce into isolated galaxies. In this process, destruction and creation occur simultaneously. This discovery also alters our understanding of galactic evolution. If galaxies can lose their central black holes, some may exist without them, while others may host black holes that originated elsewhere. Over billions of years, this redistribution could influence galaxy formation, star formation rates, and the large-scale structure of matter in the universe. The finding raises new questions. How common are these runaway giants? Does this event represent a rare anomaly, or merely the first clearly observed example of a widespread process? While some astronomers speculate that such events occur more frequently than previously thought, others suggest they remain relatively uncommon. Regarding their fate, current theories suggest that a supermassive black hole could survive in the vast reaches of intergalactic space for billions of years, possibly influencing its surroundings by accreting matter and forming new stellar objects. Could many still wander the immense spaces between galaxy clusters today? Future observatories may provide answers. Upcoming NASA missions and planned space-based gravitational wave detectors from ESA could reveal additional black hole mergers and recoil events. More sensitive instruments may also allow astronomers to map populations of previously invisible, wandering supermassive black holes. This discovery reminds us that the universe is neither static nor orderly. Even the most massive objects can be displaced and sent on solitary journeys across cosmic distances. While the laws of physics remain constant, their consequences can be far more dramatic than once imagined. A 10 million solar mass black hole has escaped its galaxy and carved a luminous path through intergalactic space. This finding overturns long-held assumptions and demonstrates that the universe continues to surprise us. The long-term fate of this black hole remains uncertain. It may eventually form a new system or drift through intergalactic space indefinitely. As astronomers uncover more evidence from gravitational waves, galaxy collisions, and hidden black holes, we will continue to refine our understanding. If you want to explore these cosmic mysteries with us, hit the like button, subscribe, and share your thoughts in the comments.